We re-begin. Section 7 is about simplifying rational expressions. I think they sometimes tilt the terms by calling it rational. Rational means making sense, logical. And rational also means ratios of whole numbers or simple things. They're not exactly the same, although the Pythagoreans really did go crazy when they found out that the square root of 2 is not a rational number. But never mind that. Rational is a ratio. It's a ratio of polynomials. Okay, polynomial over polynomial. 1 over x is a rational expression. X squared plus y squared over x squared minus y squared, another one. X squared minus y squared over x squared plus 2xy plus y squared, another one, and so on. Now you can simplify a rational expression the way you simplify a ratio. If there's a common factor in numerator and denominator, then they cancel. A times c over b times c is a over b. So for example, this expression here, x squared minus y squared over x squared plus 2xy plus y squared. Now, by using factoring from the previous section, this numerator is x minus y times x plus y. Its denominator, it turns out to be a square, namely the square of x plus y times x plus y. That's from factoring. Now, these two factors, x plus y, are identical. So we can cancel them out, and we're left with what's left over, x minus y times x plus y. And that's a simplification of this. Now you can multiply ratios and divide them. A over b times c over d, you multiply across, ac over bd, and then cancel common factors. You can divide expressions, ratios, by, well, basically by flipping the second ratio upside down and then multiplying across. A over b divided by c over d is the same thing as a over b times d over c, and multiplying across, you get ad over bc, and then cancel common factors. So for example, oh, this is a mess. 12x to the 61 over 7y to the 15 times y over 8x to the 27th. Oh my goodness. Well, you just merge them vertically and then horizontally. So the tops are 12x to the 61 times y to the first over 7y to the 15th times 8x to the 27. All right, and 7 times 8 is 56 in the denominator. 12x to the 61y over 56y to the 27th x to the 5th. Well, 12 and 56 both have a common factor of 4. 4 times 3, 4 times 14, cancel and get 3 over 14. X to the 61 over x to the 27, you subtract the powers and get x to the 34th in the numerator. Here we have y to the first over y to the 15th. We'll cancel out a y, they go away in the numerator, and left with y to the 14th in the denominator. So 3x to the 34th over 14th y to the 14th. You have the same two expressions, only divided this time. 12x to the 61 over y, 7y to the 5th divided by y over 8x to the 27th. Okay, what we do is we flip this upside down and multiply across. So you get 12x to the 61 times 8x to the 27th in the numerator, all divided by 7x to the 15th times y. Excuse me. That was probably insurance people wanting to talk about my car. Give me a break. All right, so multiplying across, multiply the coefficients, that's 96. Add the exponents, 61 plus 27 leaves an 88. Here, same deal, 7, and then 15 plus 1 makes 16. And so 96x to the 88th divided by 7y to the 16th. Adding and subtracting rational expressions, well, it depends on if there's a common denominator. If it's a common denominator, it's pretty easy. A over d plus b over d equals a plus b over d. A over d minus b over d equals a minus b over d. If there's a common denominator, then you add or subtract over the common denominator. So for example, a over 3x plus 5 over 3x. Well, we add the numerators, 8 plus 5, over the common denominator, 3x. That leaves us with 13 over 3x. Here we have 3x over x squared minus 9 over x squared minus 9. Common denominator, here it is. Subtract the numerators, 3x minus 9. However, we're not done. This numerator factors into 3 times x minus 3, and the denominator factors into x minus 3 times x plus 3. So the x minus 3 cancels, and we're left with 3 over x plus 3. Here we have 5 over x minus 3 plus 4 over 3 minus x. What's that? Well, x minus 3 and 3 minus x are opposites of each other. So we can rewrite this fraction as minus 4x over x minus 3. That plus 5x over x minus 3. Now I have a common denominator. We add the numerators, 5x plus negative 4x. And the end result is x over x minus 3. Now, if we have different denominators, a over b plus c over d, or a over b minus c over d, by rescaling both denominators and both fractions and adding common denominator, you get this: AD plus BC over BD for the sum, AD minus BC over BD for the difference. I've nicknamed this the rabbit rule because it's AD times BC over BD. So you have this crisscross shape. And long ago, I asked my students, what shall we call this? The television rule, the TP rule? Well, nobody uses rabbit ears on TVs anymore. And TPs is a bit of a stereotype. But okay, here are the rabbit ears, and that's what I'm calling it. So there we go. AD plus BC over BD, or AD minus BC over BD. So for example, 3 over x plus 2 for 5 over x minus 4. Okay, rabbit rule. 3 times x minus 4 here plus 5 over x plus 2 here, all over, multiply the denominators, x plus 2 times x minus 4. Now the rest consists of distributing and then combining like terms. Distribute 3x over 3 here, over here, you get 3x minus 12. Distribute the 5 over these two, you get 5x plus 10. 3x plus 5x, that's 8x, minus 12 plus 10 is a minus 2. And so you get 8x minus 2 over x plus 2 times x minus 4. Solves this. Okay, here, simplify this. N plus 2 over n minus 4 minus n plus 5 over n plus 4. Okay, rabbit rule. This times this, n plus 2 times n minus 4. Now minus here, and therefore minus here. N minus 4 times n plus 5 here. And multiply these out, n minus 4 times n plus 4 here in the denominator. Okay, all right, fine. Now we use FOIL to multiply this out and FOIL to multiply this out and keep the minus sign on the outside and combine and this and that after several steps that are fairly obvious. You get this: 5n plus 28 over n minus 4 times n plus 4. Now there are things called complex fractions, which are fractions made of fractions. So for example, 2/3 divided by 5/7, 4. 1 over x plus 1 over y. This is a curious one, a reciprocal of sum of reciprocals. We'll see more about this later. Here we have 2 over x plus 5, all that divided by 3 over x plus 1. Now for ones like this, which is a plain fraction over a plain fraction with no sums involved, it's easy enough. You have a fraction over another fraction, same as multiplying that by the reciprocal of the second fraction, you get AD over BC. We did that a few minutes ago. So 2/3 times 5/7 over 5/7. So that's 2/3 times 7/5. Multiplying across, 2 times 7 over 3 times 5 gets you 14 over 16. Here we have 8x to the 5th over 35y squared, all that divided by 2x to the 8th over 21y to the 5th. Okay, so the numerator times the reciprocal of the denominator. So 8x to the 5th plus 35y squared here times, here we flip this upside down and get 25y to the 5th over 2x to the 8th. Now, if you multiply across, and the numerator get 18 times 21, x to the 5th, y to the 5th. And the denominator you get 35 times 2, x to the 8th times y to the 2nd. And then, okay, after various simplifying steps, which I skip here, we get 27y to the 3rd over 5x to the 3rd. Now, another method involves what I call rescaling by product of inner denominators. So for example, this one, 1 over x plus 1 over y. Now, these have, this is a fraction, and in this part of the fraction, the denominators are x and y. That's what I call the inner denominators. So I'll rescale, in other words, multiply above and below by that product of inner denominators by xy. 1 times xy is xy, 1 over x plus 1 over y times xy is xy over x plus xy over y. And after a small amount of simplification, you get xy over y plus x. So reciprocal of sum of reciprocals is product over sum. We'll see more about that later. 2 over x plus 5, all that over 3 over x plus 1. Both this and this has an inner denominator of x, so we'll rescale by x, multiply above and below by x. 2 over x plus 5, after just multiplying, after distributing and multiplying, get 2 plus 5x. 3 over x plus 1, after multiplying by x, distributing and simplifying, get 3 plus x. So the end result is 2 plus 5x over 3 plus x. All right, here's another example. 1 over a minus 1 over b, all that a over b minus b over a. Well, this denominator is a and b inside, so ab is the inner product of inner denominators. Multiply numerator and denominator by ab. Okay, 1 over a minus 1 over b times ab is b minus a. A over b minus b over a times ab is a squared minus b squared. That will sort of do, but we can do a little bit better. A squared minus b squared is a minus b times a plus b. That underneath b minus a. B minus a and a minus b are opposites of each other. So minus of a minus b over a minus b over times a plus b. The a minus b's cancel. This minus 1 survives. This a plus b survives. And so you get -1 over a plus b is this. Here they're being deliberately complicated. And therefore so must I. X plus 3 over 4x squared minus 9 divided by this mess. X squared plus 7x plus 12 over 2x squared plus 7x minus 15. Okay, the first step is to take the second fraction and invert it and flip it, and thus turn the divide into a times. Okay, now at this point, I could refer to previous methods, but I think that would just be a distraction. Okay, x plus 3 is that. 4x squared minus 9, that's a difference of squares, name of 2x minus 3 times 2x plus 3. And for this, the AC method, after a various number of tedious steps, I'll skip right now, becomes 2x minus 3 times x plus 5. X squared plus 7x plus 12, by a fairly simple AC method, is x plus 4 times x plus 3. So far, so good. All this times all this. But they're common factors. 2x minus 3 here and here, away it goes. X plus 3 here and here, away they go. The rest stay, and we're left with x plus 5 over 2x plus 3 times x plus 4. That's the fraction. 2 over x plus 3 over x minus 1 minus 4 over x squared minus x. Okay, the first thing is to factor this x squared minus x into x times x minus 1. 2 over x plus 3 over x minus 1 minus 4 over x times x plus 1. Now, this x times x plus 1 is the least common denominator. X goes into it, x minus 1 goes into it, x times x minus 1 goes into it. All right, so we put it over that common denominator, x times x plus 1. For this, we have to multiply by an x minus 1 to compensate for a new denominator. I call it a compensator. You have an x minus 1, here you have an x minus times x minus 1, so we compensate by multiplying by an x. Then this is the same as this, so we compensate by multiplying by 1. So 2 times x minus 1 plus 3 times x minus 4 times 1, all over x minus 1. Okay, the rest is now routine. Multiply, distribute this 2, here's a 3x, here's minus 4. Simplify, 2x plus 3x is 5x, minus 2 minus 4 is minus 6. And the result then is this, 5x minus 6 over x times x plus 1. That ends that. All right, here we have another mess. X plus 2 over x minus 1 minus x minus 3 over x minus 2. All that divided by x minus 2. Okay, interdenominators are x minus 1 and x minus 2. So we multiply above and below by x minus 1 times x minus 2. So in the denominator, x plus 2 times x minus 1 times x minus 2. There it is. In the numerator, this times this, the x minus 1's cancel. We're left with x plus 2 times x minus 2. For this times this, the x minus 2 cancels. We're left with x minus 3 times x minus 1 here. And okay, at this point, we expand this, x squared minus 4 minus, oh, this, be careful, minus all this. So we have to, since this is being, we're subtracting all this, we have to keep them all in a parenthesis, at least at first. Okay, distribute by FOIL, get all this. And now, flip the sign of each of these terms in here because of this minus outside the parenthesis. X squared minus 4 minus x squared plus 3x plus x minus 3. All over. X plus 2, x minus 1, x minus 2, whatever. Now for this one, a lot of terms cancel. X squared minus x squared goes away. We have a 3x plus x makes a 4x. Minus 4 minus 3 is minus 7. So there we are. 4x minus 7 over x plus 2 times x minus 1 times x minus 2 solves this. 1 over 1 plus x plus h minus 1 over 1 plus x, all divided by h is what? This is related to something called the difference quotient, which is something you'll see all the time if and when you get to the calculus. All right, let's make life a little easier. It's all over h. Let's put this as a 1 over h in front, just to make the thing less bulky looking. And we have a fraction minus a fraction, so you use the rabbit rule. 1 times x plus h here, minus 1 plus x plus h times 1 here, over the product, 1 plus x plus h times 1 plus x. Okay, distribute the 1. You distribute the negative sign over each of this. So, and keep the 1 over h. It's important to keep it around. So you get 1 plus x minus 1 minus x minus h. A lot of terms cancel in the numerator, the 1s, the x's. We're left with 1 over h times negative h over 1 plus x plus h times 1 plus x. H over h cancels. We're left with negative 1 over 1 plus x plus h times 1 plus x. And that simplifies that. Now, here we have an expression with square roots in the denominator. That's annoying. So what we do is do something called rationalizing the denominator. The idea being to move the square roots from the denominator to the numerator. The idea being that square roots are annoying enough, but having to divide by them, oh, avoid it if you can. Well, that's the idea anyhow. So what we'll do is, the trick is we rescale by the conjugate of the denominator. The conjugate of the denominator, which is where we, instead of adding these two square roots, we subtract them. We rescale, knows we multiply numerator and denominator. Since this is a over a, which is 1, that doesn't change it any. The idea being is here we have a sum times a difference, and that equals the difference of squares, which will get rid of the square roots. That's the point. So you have this, y over root 3 plus root 5. We'll multiply by root 3 minus root y over root 3 minus root y. Since that equals 1, that won't change its value. Distribute the y over these two, y root 3 minus y root y. In the denominator, we have root 3 squared minus root y squared, because we had a sum times a difference. Root 3 squared is 3, root y squared is y. So we get y root 3 minus y root y over 3 minus y, and that rationalizes the denominator of this. Well, okay. Done for now.